Well, I had to use the ratio test to find the interval and the radius of the convergence of each power series. So basically what I did, I found my ratio test, did the A of n plus 1, you see it right here. So I did my comparison over my original, took the limit of that, so I simplified it here. And if you was to break this up, one of these will cancel out, so you'd be left over with x plus 1 over n plus 2. So I factored out my x, which I don't need because we just need to find the ratio of this and the interval between these. So when you go to infinity, you'll get 1. So back here, when you do the ratio test, you have to find an absolute convergence test. So we did an absolute value of x. So the rules for absolute, the ratio test is r is greater than 1 converges, r is less than, excuse me, wrong. R is less than 1, it converges, r is greater than 1, diverges, equal to 1, it fails. So what I did was I plugged in -1 back into the original here and did the alternating series, in which I got 0 because since the series is decreasing, it converges. Then I plugged in my 1 here back into the original, and it was a harmonic series, so it diverges. So therefore, -1 is less than or equal to if x is less than 1. So, any questions?
Good.
So, I did the same thing on the next side. But, y'all still no questions?
Was divergence?
Yes, because of this. They both have to be equal.
What do you have right here? We'll see. Oh, the
Yeah, I just did the little partial sum.
denominator.
Yeah.
Okay.
That's n1, n3,
Okay.
And on the next one, I had to do the same thing. So on 305.2, basically the same exact thing. Find my L of n, which is x plus 1, n plus 1. So I did my comparison with my original. I multiplied them across and I simplified it to x plus 1 over factorial. So I broke this down right here. N times n minus 1 minus n minus 2 over n plus 1, n times n minus 1, n minus 2. This will cancel out, so I'll just be left over with 1 plus 1. 1 over n plus 1 would equal 0. So I go back to my rule ratio test. And 0 times the absolute value of x is 0, so it converges. Any questions on that?
You went from your x's to n's. Is that what you did right there?
I probably supposed to put an n, but wrote the x.
Oh, okay.
Right here?
Okay. Yeah.
Yeah, it's supposed to be an n. I wrote the x. No, that's right, x, but I just wrote it out because you'll have this right here over xn and 1 over xn. Yeah, cancel. Oh, yeah, you
Yeah. So, no, but see, I'm confused right now because down here, like, you have your n times n minus 1 minus, yeah. You have n's on your up a little bit. Where you, yeah, right there. You have n's on your numerator and
This was
denominator.
so I can break this. So I just showed y'all the work, how I canceled everything out to get to here. You see what I did? That's basically showing this, what I did. So that's the factorial. So you know the factorial, you go from 1, 2, so you keep going up.
Yeah.
I go down. So that's basically what I did, and it's going to cancel out.
I just don't see why you have n's in the numerator when you have a 1 up there. See what I'm saying?
And,
Are you expanding off of this 1 over n plus 1 at factorial?
I don't even see what you got right here.
Yeah. Is that the same thing?
All right. What I did basically was, I got this from here, right here.
Yeah.
So instead of just the problem right here, breaking it up, just to show y'all that it's going to cancel out to this.
Yeah.
So I'm left over with 1 over xn because xn over xn is going to cancel out. So don't worry about it. So I got 1 over xn, which you are right. It should be n. Should be 1. And it's going to cancel out. Okay. And you get back here, so that's how you know it's 0. Because you plug in infinity to get 0. And 0 is less than 1, so it converges.
Alright, so like going back to 305.1, you have to use the ratio test to find the interval of convergence. Is that what you did? Okay, so you found that the absolute value of x is less than 1, and so that's the interval of convergence, right?
Say that again? Say that again?
The interval of convergence. Because when you take the limit, you get that it's what? It's x, right?
No, the limit of this one is 1. I just did my absolute convergence. And so, you know, when you do absolute convergence to ratio, you have to do the absolute value. So I multiplied that, and that's when I went back to the rules of ratio test. R is less than 1, convergence. Greater than 1 and divergence equal to 1. It fails. So that's when I did the equality things. That's what it's called.
Inequalities.
Equality things. So that's when I plugged these two numbers back into my original and did the
Like
alternator.
what I'm seeing right now is you have the x times the limit as an equation to infinity.
This don't. You're not worried about this because our main focus is on here, the convergence. I don't know what the problem actually is. I got it. So the x right here is basically nothing. It's like a constant. You're not worried about our constant anymore.
You said you got 1, right?
Yeah.
According to this thing, it said the test failed.
You got X.
You got X.
You got
Okay.
x. So x is not like 1. That's what I'm saying.
Okay.
You know what I mean?
Because these power series is like, it's telling you that you can put the power series as like a function.
Mm-hmm.
And I think what the interval convergence is asking is if that x can be like, I don't know, it just tells you something about the interval convergence from what I remember.
I don't know.
Maybe
From
you
like
should-
for a while you asking, I don't know. I just
It's all this.
I mean, you still can't take that X out though, right?
yeah. It's just not even
Do we all
there.
agree that you can't take the X out?
It's gonna have to be there. You talking about this right here? You talking about this x, right?
Yeah, I was talking about.
It's just a constant. I just took it out so I can focus on this.
Because, like, the thing I'm confused about is that you have that it diverges, but this question isn't asking whether it converges or diverges. It's asking for the interval of convergence and the ratio of convergence.
Oh, sorry.
They're asking.
That's totally different.
Yeah,
Where's it coming
yeah,
from?
That's totally
They're
different.
asking, what is this problem asking for you to do?
It says
Yeah.
use the ratio test to find the interval and the ratio of convergence of each power series. So I'm saying it's convergence over here because, which I guess that's probably wrong. I don't know. We have to get back to y'all on Monday.
Okay.
So put the
Is that x
to waste
times
without wasting time.
Yeah.
Yeah.
Oh, I'm taking the shit, dude.
We have 2